Hi guys. So today we are going to discuss about Rust. It's I'm pretty late, I know, but um, that's fine. I was just having some problem in setting up my uh, camera, but it's still not up. But that's okay. Okay. So let me quickly share why Rust. Uh, okay. Yeah. So if we compare, so yeah, first of all, Rust is a programming language, um, and it's considered to be better than C++, and C++ is of course better than C. So as compared to other languages, this is the comparison for Rust versus all other languages. So Rust has, let me open it on a better page rather, I'll say. Just give me a second. My camera is not working though. So, okay. Yeah. Uh, Let me open up my Git page. Okay. So yeah, so Rust versus all other languages, Rust, and on comparison, Rust has no garbage collector as we have in Java, Python. The garbage collection is heavy, so that's why Rust avoids it. Then Rust is statically typed, that is, it has type interference and it catches bugs at compile time and reduces the runtime crashes. This is one of my favorite. We'll see this in example. Rust also does not have any type confusion as we have in Python. We do not specify types. In C++, we do specify types. For example, we have something as int a, char b, and so on. In Python, we don't do that, but Rust also specifies the types. Um, then Rust also provides a very good memory safety. Just let me share. mm, Share. Okay, window is fine. Okay, let me share the notepad so that I can write as well. So yeah, Rust uh, provides thread safety. That is, there are no data races, no two threads doing same thing um, on a shared resource have a data race condition. Now we have a concept of arc in Rust, and it's pretty good. Then Rust has a concept of memory and ownership checking. This is pretty nice. We'll be discussing this when we go ahead. And we don't need to call um, delete or free after allocation as we do in C++. So Rust automatically has a concept. Uh, for example, the smart pointers inherently implemented, which actually does all the deletion uh, for the memory. So in Rust, we have RC, that is RC templated type for the sharing ownership. That's a reference counter, and we have boxt, which implements a drop trait. Trait is in Rust is same as the virtual class in C++. So we'll be discussing that as well. So Rust versus C++, it has, this is actually, this is very good thing that Rust has no implicit copies. For example, we have a function something like this. We have int main, and in C++, I'm telling you, we have int a is equal to 10, and or let's suppose we have an array uh, which has 10, 20, 12, 3, 5, and so on, some elements, and we pass this array to a function. So we have int fun, which takes the array and does some processing. So here, if we see, whenever we pass a array to a function, a copy of array is created, right? So we can change anything in this array. For example, a1 can become 50, but in original array, the a will still remain 12. So there is a copy. And if we have huge data to be copied or a lot of data to be transferred between the functions, copying becomes heavy. That's in C++, but Rust avoids it. There are no implicit copies until we specify a clone of it. Then Rust uses, let me delete this one. Then Rust uses a LLVM compiler, which has advantages over G++. There are no invisible copy constructors, move constructors as in C++. So if we'll be seeing this copy constructors when we'll go into the C++ course, but Rust do not have those. Then it has safe parallelism. It exposes shared libraries as crits, which is far better managed. In C++, we do not have a repository of the libraries which can be used by the programmers. We have a crits.io library managed by Rust. Compiler errors are more informative. We'll see this. Memory safety, no segfaults. That's interesting. And that's really very good. Okay. And no memory leaks, no out of bound read writes, no double freeze, no dangling pointers, and so on. Right. Okay. So before moving ahead into the Rust installation steps and any other thing, let me just quickly go on to a simple comparison between C++ and Rust using a code. Okay, so I am on Ubuntu terminal. Let me go into the C++ code and try to do some bad stuff. Okay, so here, let me delete this. Okay, so let me delete this either also. Okay, so I'm into the main. I have taken an array of size 2, so it will be something as array as uh, it will be something as this. This will be the 0 memory location, this will be first memory location, and there is no third memory location. That is, only two elements can be stored. First thing is a2 is not initialized. It will take a garbage value, which is bad. Then in b, integer b is assigned to a memory location which doesn't exist, right? We have only 0 and 1. Even a2 doesn't exist, a3 doesn't exist either. So this memory location is a0, and if we say this is a1, so only two memory locations for array. Let's compile this. G++ test.cpp. Oh, voila, we the code is compiled. That's better. Let's try to print the value of b and see what happens. Compile it. Cout not declared. Okay, let me hash include iostream. So this is just for the comparison with C++. Let me run it, and it gave some garbage value. Let me run it again. It gave another value, another value, another value, and so on. Okay, that's not good. We do not want it. Let's go to Rust now. So in Rust, we'll have extensions as rs. Let me open this array.rs. In place of int main, Rust starts the code with fn main. We have taken an array. So see here, we have to specify the type. It's of type i32. There are two elements. We have taken 1 and 2. So again, the array will be something like this. It will be array 0 will be this, and we'll have array 1 is this, and we'll have 1 and we'll have 2. That's all. So now we are trying, uh, this will be 0 index, this will be 1 index, pretty same. Now we are trying to initialize b with 2, which doesn't exist. Okay, C++ has allowed it. Now see what Rust does. So in Rust, we have a compiler as Rust C, which I have already installed, array.rs. Oh, Rust gave us a compilation error, and it says index out of bound, length 2, but index length is 2, but index is 2. That's good. It says that we have a sec 2 element array, and we are trying to get an index 2 which is out of bound. So that's fine. And what it says, if this is intentional, prefix it with underscore. Oh, that then again it says that we have not used, if this is intentional. Okay, be unused. Oh, that's pretty good. So for every unused variable as well, it says that if it is unused, then prefix with underscore. By the way, all the unused variables are prefixed with underscore in Rust. So one warning, one error, and that's good as compared to C++. That's fine. So now let's go to the Rust book and start from there. But I'll recommend uh, reading C++ or C first, and then going ahead with Rust, because Rust, the learning curve in Rust is pretty sharp. So I'm using this book, Rust Programming Language book, and it's from uh, Steve Klabnik. Okay, so let's go directly onto the chapters. Okay, okay, so for installing on Linux, we can use this command, and it'll install the latest Rust C version, which is 1.69.0. For installing in Windows, you have to go to rustup.rs and follow the instructions from there. For updating you have to do rustup update. So I feel and I believe that you'll be doing all these steps by your own. Okay. So in Linux, we will be creating some directory as projects. We'll be going into projects. We'll be creating another directory, hello world, and we'll be going inside the hello world. And then we are simply writing a program. Something is hello world. And then we are running with the Rust C is a Rust compiler, as we have a GCC in for C and G++ for C++. Um, so when we run /main, it will give us hello world. That's fine. Okay, so let's see the anatomy of Rust program. So this line actually defines a Rust function. In other programming languages, for example, in Python, we have def and the function name. In C, we have int and the function name. In Java, it's pretty same as C, C++, that is int, void, and the function name. So we can compare the languages. It becomes easy. The main is special. It's the first thing that is run for every Rust for every executable Rust program. So, as in C++, um, and Java and C, Rust also goes into the main function. So this main function doesn't have any arguments. So arguments are specified inside these brackets. And the function is wrapped inside these curly brackets. So that's same as all other programming languages. So here we have a first line, a first function, which is println. So anything which is preceded by this dollar sign, this is a macro in Rust. So we'll be learning about this as well. And if we do not precede it with dollar, it becomes a function. So that's fine. So I'll be moving ahead pretty quickly. Every statement is preceded by a semicolon as we do in C, C++. So it's pretty similar to C++, rather, I'll say. Okay. So now we are jumping onto the cargo. So cargo is a Rust build system and a package manager. For example, we can consider cargo as a repository where we have all the crates actually defined. So crate is nothing but a shared library, .so file in C++ or lib file in C. So we have a crate in Rust. Uh, okay. So a pretty cool thing in Rust is you can create projects using cargo. So let me demonstrate it how. Okay. So if I want to create a new project, let me say I want to create some number input thing. So I'll do cargo new number input, and it'll create a binary application. So in Rust, as we have in C++, in C, we have binary and we have a library. So this creates a binary application. Then let's go into, let me show you what it created. It created a directory called number input. So let me go into number input, and then it has provided one directory and one file called cargo toml. So what's this cargo toml? Cargo toml is a file which contains the definition of all the dependencies which we'll have in our project. So dependencies might be if you want to use uh, some library for serialization, deserialization, or if you want to use some library for threading, if we want to use some library for random number generation, for example, then what I can do is rand is equal to the version number, for example 0.1.0, and it will go to the crates.io, find this crate, it will download it for us, and we can use the functions which are present inside this shared library. Let's go to this. So this package actually name is number input, version is first version, this is the author, then this is the edition. uh, you can change it anyways. Okay, so let me skip adding dependencies for now, and let me go to the source. So source has only one file as of now, which is main.rs. Let me open source and main.rs. It already had a hello world written for us, and we can run this using cargo build. With the cargo build, it builds the current program for us and it generates few more files. That's good. So it generated a target. Let's see what's there in target. Okay, it generated debug, and in debug it has generated executable for us. That's nice. And if we have specified cargo build release, will it work? Oh, it's working. Let's see what it does. Let's go into the target and let's see. So it has given us a release binary as well. So let's see the size of release binary. It's 3342720, and let's see the size of Oh, this release binary is smaller than the debug binary. So if we want to specify, we want to provide a release to our customer, or like we want to deploy it without debug symbols, then we will provide a release binary. So let's understand it more. Okay, so let's see what's there in cargo.lock. Oh, nothing. So basically, cargo.lock file is useful when we use different crates. So it actually locks the crate version for this project. And once we do cargo update, it can update the version. So in nutshell, we'll have a main.rs in which we'll be writing our code. For example, in this present program, we have hello world. And if you want some what I can say more uh, code. Let's suppose uh, we want to take input from the user. Okay, so in that case, we will be writing some more code. Let's do that. Okay, hello world. We'll do the same. Enter number. So this is same as printf in C. Now in Rust, we create variables using the let statement. So in C++, if you remember, we have int a is equal to 10 or something. But in Rust, we have let a is equal to the type which we defined here. So if we want to enter let a, let's not take this. Let's take a I32. And in C++, everything is mutable, right? That means it can be changed. But the good thing in Rust is everything is immutable. That is, cannot be changed. So if I do here something as, first of all, it'll ask me to initialize. Let me initialize with 9, and then let me do a 10. So what it will say, let's say, see that cargo build. So it says cannot assign twice to a immutable variable. So we have to explicitly make a variable mutable in Rust by specifying a mute statement. And then let's compile it. So it compiled, finished, but it has given the warning that A is not used. We may use it later. So that's also good, that if we do not want to change the variable, it's sort of a const. In Rust, everything is const by default. Everything is const by default in Rust. That's cool. That avoids a lot of mistakes actually, right? So let me take, let me make this variable as unused variable. So unused variable can be prefixed with underscore, and let me take uh, something as text. I'll take it as a string variable. So in this line, I have taken a variable named text. It's mutable, means I can add a value to it, change a value, and it's of type string. Then I need to do a IO input output library. In an input output library, need to add a input library provides us stdin function in which I have a readline function, and in readline function I will be using text to read from the standard input. So let's compile it. It'll throw error because we have not defined the IO crate. Let's define it. I'll say use std IO. So IO basically in Rust. So IO library comes with standard library std, which is provided by Rust. So if you use stdio, we can access all the features, functionalities related to user input provided by the library. Let's try to build it now. Okay, that's cool. It built it, but it has given one warning. That's very interesting, right? And that's very good thing about Rust, I feel. So here it says that the function, this read line actually returns two things. So basically it actually returns a result. Okay, so let me open a file and tell you how it works. So uh, this read line actually returns, it doesn't return an integer, it doesn't return um, a string or anything, right? It returns a result, and a result can be of two types. Either it can be okay or it can be error. So what we can do here is we can do something like this: let a, or let test, or b, maybe let b is equal to this, which will match it, and we will be doing a okay, where we will do something as, if the read line returns fine, then this is, and if it returns error, so in that case we will print the error. We'll say println not error, and we'll say e, and we can initialize empty to b when a error returns. So what we have done here is we have written a match statement, because we know read line returns okay or error, and in that case, in case of a okay, we just initialize this b to this b, which goes to this b, so correct result. But in case of error, we have just printed the error, we have initialized the empty string to b, and we have moved ahead. And what it says, it may result the error variant which should be handled. That's cool, right? Rust says that our function can fail, but you in advance handle this error, so that whenever it occurs, you get a message or you could do some sort of handling. So let's do a cargo build here. Okay, so it says expected usize found string. Okay, let me change it to usize. And this also says this, change as usize. Let me prefix with underscore. Oh, it's built. But what we can do is we can just print it again. B is equal to B. So in Rust, as we are aware in C, or C, in C basically, if you're aware, we have a printf statement where we use to specify percentage %d or percentage %f or percentage %c or percentage %s type specifier, format specifier, and then we used to provide the variable values, something as a, b, c, and d. But in Rust, everything can be printed using these angular brackets inside the println. Okay, so let's do a cargo build. Then let's do a cargo run. It's waiting for our input. Enter the number. Let's enter 4. It gave 2. Is it error? Okay, it has taken text and it has given us 2. Okay, so we have taken B. Where is B? Okay, we have taken a string, we have done IO, stdin, readline, mutable text, and we have provided a guess. Okay, in place of this, we can also provide Let me copy this YYP, and so this is the how this match is actually handled. We can provide a expect as well, and you can say failed or something. So this will get the value inside the text, and then we can say text is equal to text. Okay, let me do a cargo run, and then we let me provide 4, and the text is 4. That's good. Let me provide some other value RT, and the text is RT. Okay, so this is how the Rust actually works. So yeah, so I think we can just pause here, and if someone has some doubt, we can take it up. Mm, and we'll continue. Maybe let me open the book again. So basically, this expect um, crashes the program or makes the program die whenever we have something wrong, and provides a meaningful, like reads meaningful if we have something good. So for example, where is that accept thing? Generating the secret key. Okay, that's a guess game. Anyways, so we will be, so okay, so about this program, we have the main function, we are reading from the standard input, and then this is immutable, we have made it mutable. We are taking a reference, mutable reference, so we'll be discussing about the mutable references later as well, and we are doing a expect on this. So the instance of IO result has an expect method that we can call. If the instance of IO result in an error, expect the program to crash. Otherwise, it displays the message that is passed as argument to the expect. Then we have done a cargo build. Rather, we have done a cargo run and we have seen it. So I think that's all. So guys, thanks a lot. Uh, we'll catch up uh, in another. So if the car has asked that what for what kind of application we use Rust. So Rust is basically used for any kind of application which we do for C++. For example, microservices can be built in Rust. Um, then lower level applications, device drivers are nowadays written in Rust. Uh, if you we have a lot of openings in Amazon related to Rust. They are porting a lot of their code in Rust. Then Microsoft also has is porting their major applications in Rust. Uh, some uh, some some companies are writing their kernel also in Rust, so it's pretty safe. Like it avoids all the runtime errors which it catches on the compile time. So that's why it's pretty safe. Like until date, there are very few null pointer exceptions which are reported in Rust as compared to C++. So that's how it is. So yeah, thanks a lot, guys. Maybe we'll catch up later. Bye.